supposed to do it, Dad. They want us to do it this
I don't
way.
know that way. Why would they change math? Math is math.
okay,
Math
Dad.
is math.
Hi Year 9, welcome back to your next lesson on Mathematics. We're starting off the video today with a few rebus puzzles. If you think you can figure out what the common sayings or phrases are in these three pictures, let me hear about it in the comments below. Prizes for correct answers. Alright, we can start off the video as always with some flashback questions from previous lessons. So I want you to pause the video and see if you can remember how to factorize these four expressions. Okay, now you've done that. For the first one, we are looking for a common factor between the two terms. So a common factor of 40 and 25 would be 5. And the common factor of x cubed and x squared y would be x squared. So we'll factor that out the front. Now out of the front term, we'll be left with 8x. And out of the second term, we'll be left with negative 5y. And there is our factorization. For the next three, we have some quadratic trinomials from the previous video. So as always, we've got to set up a pair of brackets. We're going to have an n and an n to make the n squared. And now we're trying to fill the gaps with two numbers that add to give 10 and multiply to give 21. It's a nice easy one. We're going with plus 3 and plus 7. Okay, for C, a little bit tougher. Once again, we've got the trinomial, so we'll set up a pair of brackets with two h's. Now we need two numbers that are going to add to give positive 1 and are going to multiply to give negative 30. Magic numbers this time are going to be 5 and 6, but one of them needs to be negative. Because the sum is plus 1, it means that the bigger one is going to be the positive. So we're going to have plus 6 and we're going to have minus 5. For question D, first thing we're going to do is take out the common factor of 2 out of all three terms. So we'll have 2 outside of x squared minus 8x plus 15. Now factorizing this, we're thinking of two numbers that need to add to give negative 8 and they're going to multiply to give positive 15. For this one, it's going to be minus 5 and minus 3. So well done if you got that answer with the little 2 out the front. Okay, our next lesson today is on what's called difference of squares factorization. So that will be your heading in your notes. All right, we're going to start off by looking at some expansions that we did earlier in the year that we also called difference of squares. They would have looked like this. I want you to think back and see if you can remember the shortcut that we were using a bunch of times to expand these two brackets in one step without having to do a FOIL. Okay, so if we do a FOIL expansion, what we're going to notice is that our middle terms, for example, in this first one, we're going to have a 3x in the middle and we're going to have a negative 3x. Those two terms are going to cancel off, so we don't even bother writing them. We go straight to the answer and we write x squared take away 9. Okay, that's x times x and then 3 times negative 3. Similar deal over here. We jump straight to the answer. We do 2a times 2a to get us 4a squared. We do minus 5 times 5 to get us minus 25. Now going from top to bottom is obviously called expanding. Today we are working from the bottom up and we are trying to factorize, which is not too challenging. All you've got to recognize is that when you have two terms that are a difference of squares, you've got to say to yourself, well, what are the square roots of these two pieces? Well, the square root here is x and the square root here is 3. So we do x plus 3, x minus 3, and then you're done. Okay, it's very quick and easy when you know what you're looking for. Similar deal over here, the square root of 4a squared is going to be 2a, and the square root of 25 is 5. So we do 2a and 5, added and subtracted in two brackets. Doesn't matter whether the first bracket is the plus or the minus, because the two brackets are multiplying, the order is not important, because if you think about it, 2 times 3 and 3 times 2, they get you the same thing. So order is not important. All right, so in our notes, we're going to put that a squared take away b squared can be factorized as a plus b and then a minus b multiplied. And that's called the difference of squares. Let's have a look at some examples to get a better understanding of what's happening here. Sorry if you're picking up a bit of wind. It's very windy when I'm recording this, but I cannot control the weather, so I'm really sorry about that. Okay, starting off with some milder examples. So for the first one, we are looking for a difference of two squares, and what do you know? We have it right here. 36 is 6 being squared, and b squared is, of course, b being squared. So we take those square roots and we just add them together and we subtract them. So we've got 6 plus b and we've got 6 minus b as our two brackets, And there is your factorization. For question B, we think about the square roots. So the square root of 16m squared, that's going to be 4m. And the square root of 100 is going to be, of course, 10. So we're just going to take 4m and 10. We're going to add them together. We're going to subtract them. And we're going to put them in a pair of brackets. And then we have factorized. Lovely. Okay, last one's a little bit scarier, but it's the same process. We're going to take the square root of 64y squared, which is going to be 8y. We're going to square root 4a squared b squared, which is going to give us 2ab. So we have a difference of two squares. So we factorize it as the square roots, plus and minus, and voila, what do you know? Quick, easy, beautiful mathematics. What a treat for you guys. Okay, those were some warm-up questions. Let's try a few little spicier ones to really get you guys thinking. So with this first question, we have a difference, but we don't quite have a difference of squares because 2 and 50 are not square numbers. So we're going to try a different tactic. What we're going to do here is we are going to factor out of both terms a common factor of 2 because 2 goes into both 2 and 50. So if we factor it out, we get 25v squared at the front term, and we get 1 for the second term. Now that we've done that, now what's inside this bracket here is a difference of two squares. We've got 5v being squared here, and we've got 1 being squared here, of course, because 1 times 1 is 1. Fun fact. So we'll factorize this as 5v plus 1 and 5v minus 1. And there in red is our fully factored form with the 2 just chilling out the front by himself. Okay, question B. Once again, 5 and 80 are not square numbers, but they are a common factor of 5. So we'll factor out the 5, which leaves us with t squared here. 80 divided by 5 is 16. And now what do you know? T squared and 16 are two square terms. We can factorize this as a difference of two squares. So we'll have t and 4 plussing and minusing like this. 5 still chills out the front. Okay, and C's got a bit of extra spice. So 9 and 4 are both square numbers, so we're good to go on that front. We've got 3 times 3 and 2 times 2. Now we've got to think about x to the power of 4. Is that something being squared? Well, let's think. What is x squared multiplied by x squared? What do you know? It's x to the power of 4. So x to the 4 is actually x squared squared. Likewise, y to the power of 6, that's y to the 3 multiplied by y to the 3. So y to the power of 6 is y cubed squared. So we have our square roots being 3x squared for the front term, and we have 2y to the 3 for the second term as our square roots. So to factorize, we've got to take these two blue bits, we've got to add them and subtract them, put them in a bracket, voila, there is your answer. It's not super beautiful, but it is super correct. Okay, we're going to look at a few optional challenge questions now, because I know some people in our class do like to sort of push their mathematical knowledge, but these questions will fall under the category of optional for beginners today. You may want to come back and try them later when you're feeling more confident. So here they are. The first one is a to the power of 4, take away 1. Okay, so like with the last example, we're going to think of a to the power of 4, and we're going to say to ourselves, well, that is just a squared squared. So that is a squared term. And 1 is, of course, 1 squared. So this is, in fact, a difference of two squares. So we'll factorize it as a squared take away 1 and a squared plus 1. Now, I want you to look really closely at this front bracket for about 5 seconds and see if you think of anything really clever. That's correct. A squared take away 1 is also a difference of two squares. So this bracket here can actually be further factorized. We can split this up into a minus 1 and a plus 1 as the square roots. So the blue answer there is a partially factorized answer. The red one there is a fully factorized answer. And if any of you are brave enough in year 12 to choose extension 2 maths, I will show you how to factorize a squared plus 1. It is possible. You just need to use a bit of mathematics called imaginary numbers, which is a long story, so don't get me started. Okay, question B. We've got some scary looking fractions, but we do actually have a difference of two squares. For the front term, the top m squared is obviously m squared, and the bottom is 3 squared. So this entire fraction is actually m over 3 all squared. That would get you m squared over 9. Second term, we've got similar stuff. We've got 4n squared on the top. That's 2n all being squared. And on the bottom, we've got 5 squared. So this fraction right here is the square root of this fraction. We have a difference of two squares, so we're going to add these and subtract these and put them in some brackets, please. All right, and for C, it's a super gross one that we've got to do a bit of work with first. First thing we've got to do is we've got to write 1 1/4 as an improper fraction. So 1 1/4, aka 5/4. Now looking at these two numbers, they don't really look like square numbers to me, but we do have a common factor of 5 that we can yank out the front and look like this. So if we pull 5 out of 5/4, we get a quarter. 5 out of 45 gets us 9. Now again, this may not look like a difference of two squares because it's a really gross question, but a quarter is actually a half multiplied by a half. So a quarter is a half squared. 9 is of course 3 squared, and x to the power of 10 is x to the power of 5 multiplied by x to the power of 5. So this is x to the power of 5 squared. So it is actually also a difference of squares, and we can factorize it like this. All right, the 5 is still chilling out the front. We've got the square roots of these two terms, plus and minus. Now, excuse me while I do a bit of a gross cough off camera. Will I edit that out? Pretty unlikely. I'm pretty lazy. All right. Now enough yabbering from me. I'm going to get you guys to pause the video and see if you can try some of these questions by yourself. Be careful with E. It's a bit of a trick question, but A through D are fairly straightforward. See how you go before I spoil it. Okay, spoiler warning. Here is the first one. The square roots of p squared and 121 are p and 11. So if you did p plus 11 and p minus 11 in any order, you are a goddamn genius. For the next one, our square roots are going to be 7 and we're going to have 9x here. So we're going to take those two square roots and we're going to add and subtract like this. For question C, the front term is 2ab being squared and 1 is of course 1 squared. So we'll take those two answers and we're going to add and subtract in a couple of pretty brackets. Now question D steps up a little bit because 3 and 12 are not square numbers. However, they are two numbers with a common factor of 3. So we can factorize the 3 out the front and leave us with d squared take away 4w squared. And now what's inside that parentheses term is in fact a difference of two squares. This is d being squared and this is 2w being squared. So we'll do d minus 2w and d plus 2w, 3 still chilling out the front as always. Okay, question E, the challenge question. So t to the power of 4, we've got to think of that as t squared squared, and we're thinking of 81 as 9 squared. So we're going to have t squared plus 9 and t squared minus 9. Now that's a pretty good answer. We can actually improve upon this, because like on the last slide, this question is a bit of a Russian nesting doll of factorization. There's another layer here that we can keep unstacking. All right, t squared plus 9, there's nothing we can do with that because it's a plus. But t squared take away 9, what do you know? That's a difference of two squares. This bracket can be split apart into t minus 3 and t plus 3 to get a fully factorized answer. All right, so well done if you got blue. If you got red, you are amazing. All right, that's going to do it for today's examples. You guys can have a go at some of these exercise questions in your maths book. Pick 2 or 3 of these columns. Anything below the red dotted line is optional challenge work because they get pretty gross. Everything above the red line, I think you guys can handle. Be careful with this last line here. They're pretty tough, but everything else you guys should be all right with. As always, hit me up if you need any more examples or if you're confused with any of the questions. If not, I'll see you guys in the next video. Thank you so much if you watched this far. See you next time.